Welcome to Friday, everybody. Hoping that you're well at this point in time. There's a web page that has a bunch of memes that describe the current state of quarantine and something. And this was one of my favorite ones, day 6 of quarantine. So hoping you're not feeling this way, that you're feeling a little bit better than the chicken in Moana. If you are getting a little bit stir crazy, hopefully you'll get the chance to spend some time outside, maybe take a little walk and maintain appropriate social distance. Or if you're bored, you're welcome to drop by my virtual office hours from 2 to 4 today. I'd love to see and catch up with all of you. I just wanted to take a minute to thank so much for all of your hard work that you put in so far this week. We've been coming down to the wire on our AP Computer Science content for this year. We'll kind of wrap it up next week. And I really appreciate how hard you all worked in our new circumstances. So let's keep going. The last couple of class periods, we've been studying 2D arrays, the ways that they can store data, the ways that they are organized. And last class, we kind of left off with learning how to access the values within them. In my opinion, here's kind of what we've learned so far. We've learned how to make them. We've learned how to access their contents using their indices. So you guys solved some problems where you wrote the indices of 2D arrays down and accessed them yourself. We've also learned last class how to loop through them using double for loops and come up with some basic algorithms to edit them. Now that we've got this kind of double for loop code going, I want us to get a little bit more advanced with how we use these things. We'll use our knowledge today of indices to process things by their row and column. We'll also analyze row and column dependent algorithms in 2D arrays. So what we're getting at now is the ability to understand what a particular algorithm is doing, and also seeing how the rows or columns that something is in can be used to our advantage, where we can analyze something based on its location. When you submitted your homework the other night, many of you noted that having some sort of grid system or a map with coordinates was a great use of a 2D array. That's a way of understanding a value based on where it's located, and we'll start to look a little bit at that today. As we get into next week, we'll actually spend a little bit more time writing individual code using 2D arrays to process and analyze large amounts of data, and we'll try kind of the basics of that here at the end of class today. So our agenda for today is to do some familiar things. We'll trace some double for loop code. We'll practice writing column and row dependent algorithms as a class, and then you'll have the chance to practice tracing for loops on your own in your homework assignment for tonight. Okay? If you're with me, I want to just draw your attention to the Haiku page for today real quick. If you look at the agenda, you'll see our instructional video that you clicked on. You'll see the example note sheet, which is what I'm going to edit today. This note sheet will be something that you already all have a copy of, but it'll have all of the comments and things that I note on it as we go through class today. Your copy of this assignment is available on Google Classroom under Analyzing 2D Array Algorithms IP. And it's the exact same thing, except it just doesn't have my comments and work on the notes part of it that the Haiku link has itself. So if you want a completed copy of this, or the first half of this, look at Haiku. If you want to look at your own blank copy and have some space to work and have some space to write things down, you can do that today as we go along. Notice at the bottom of this Google Classroom is your homework for tonight. So the top half is notes. I've got 3 additional multiple choice questions here. And at the bottom is some space for one additional open-ended question that a friend will ask you at the end of class today. So we'll go ahead and get started. You've seen a million AP questions this year where you've had to trace through how a for loop is affecting the code in an array. And our goal for today to kind of start things out. It's just to get used to doing this with 2D array algorithms. Now, we use tables to do this already, and there's going to kind of be a slightly different method for doing this. When we're working with 2D arrays, some tools that I think are helpful. Take about a minute, read some guidelines to yourself about what could be good in the code in 2D arrays. Read the guidelines on the page, and then I'll read them out loud as we do our first example. Now, I'm going to go to the master copy of the assignment. You can go to your own if it's helpful, but I'm going to draw your attention to what I think is helpful when you're thinking about tracing rules for 2D algorithms, some steps that could be helpful for you. Okay. When you do this with for loops on 1D arrays, we would always make a table and we'd show how things are being checked over time. That can be a little trickier when it comes to 2D arrays. So here are some steps that I think are going to be helpful for you. Let's try them out on our first example of tracing code. So I've got a 2D array right here. Okay. I have got some for loops that are running through this thing. Take about 5 seconds. Recall what each of the 2 for loops on this thing does. My outer for loop is always running through the rows, both different 1D arrays. My inner is running through the entries in their columns. And as another little review from yesterday, remember, this returns the length of each 1D array. This returns the number of rows. So the problem for today is that mat jk is equal to 10 times k plus j at any particular value. That's what we will do here today. So let's spend some time labeling some of these examples as we go through. First things first, we want to label what variables represent rows and columns. We've already done that. J is rows. K is columns. Here in class today, so I'm good on number 1 here. I'm going to use a lot of Google comments to do this, which you might find also helpful as you try this out yourself. Label the if statements and what they're checking. We don't have any if statements in this problem, so we can kind of ignore step 2. Label the array parts to explain what parts it's looking at. Here's my array part that pops up here. What the easiest thing to identify is whether you're accessing the entire 2D array, like in mat.length, whether you're accessing one of the 1D arrays inside of this thing, like mat0.length, or whether it's accessing a specific index or value, like one specific number within the 2D array. So because this has 2 numbers in it, it's accessing the value at the index of jk. The other important part of understanding our array is, again, making sure we have our definition. 3, 5 means this thing's going to have 3 rows and 5 columns. And that actually makes it super easy for us to eliminate some options. 1, 2, 3. 1, 2, 3, 4, 5. This has 3 rows and 5 columns, so it could be option A. 1, 2, 3, 4, 5. 1, 2, 3. That one's flipped. So it can't be this option. Same with this one right here. So we'll already be able to eliminate B and C as we go through based on their size. So the way that I like to do this is I like to make a table that's one bigger than the size of the array. And edit it as we go through. Remember we said J is going to be our rows. I always start from 0. And K is going to be our columns. And the way that I like to do this is edit these as time goes on. Now, let's find our condition. Mat JK, so the value that's actually going to go in each of these boxes, is equal to 10 times K plus J. So that's pretty easy to start out. K is 0, so 10 times 0 plus 0 is going to be, as a class, yeah, 0. You're totally right. 10 times K, which is 1, plus 0 is going to be 10. Now let's go to our second row. 10 times K plus 1. So it's K 0, J is 1. We get 1. 10 times K is 10 plus 1. It's going to be 11. 21, 31, 41. And last but not least, we're multiplying by K, which is 0 one more time and adding 2. So I get 2, 12, 22, 32, 40. There's the values that will actually be saved into each one of my array pieces. And based on the table that I made, looks like D is going to be my correct answer on that one. There are 2 additional examples here that tend to get a little bit harder. So what I'd like you to do, go ahead and pause this video. Go to number 2, complete your 4 steps and pick an answer. Go to number 3, complete your 4 steps and get an answer. As you look at number 3, you'll notice something, that there's a for each loop right here. Comment on what you think it means. Once you've answered just example number 2 and number 3 for these multiple choice problems, go ahead and press play and move on to the next video.